I've got a project that's gonna revolutionize the way you do hydrodynamic testing. It's got volumetric flow rate. It's got largemouth bass. It's got laminar flow, hopefully. We're making the fish treadmill!
Whoa! Let's go get some fish, let's go! Let's go! Wait, keep off the ice. So do all mechanical engineering majors begin design in the fall of their senior year and then build it in the spring?
I can't think of a building project that wouldn't start with design. Engineering is design. Dr. Anderson says the difference between tinkering and engineering is the thought and effort that goes in before any physical component actually comes together. And so you need to be very familiar with the principles of physics and thermodynamics and all that great stuff, and then use those to optimize the parameters of whatever it is that you are building. I'm on the water tunnel team, so our job is to make a water tunnel, also called a flume, for Dr. Anderson so that he can use it for his hydrodynamic testing of various fish species that are local to Pennsylvania.
That's really cool.
Yeah.
Okay, so I'm assuming if your project is about fish,
Yes.
you probably come down to Wolf Creek here and collect various samples and measure them for your project. Is that what you've been doing all semester?
Unfortunately not. Funnily enough, Dr. Anderson suggested catching a few fish species, chopping them open to see what the cross-sectional areas are like, but he didn't want to do that because of all the paperwork that we'd have to fill out.
Ah, red tape.
We are very close to the building stage. As of yet, we have fully designed and modeled the flume. That was after extensive research on how to make a decent flume, how to achieve pretty good flow rate, and also the proper size of each component of the flume. And we just ordered our first materials yesterday, that being acrylic sheets and PVC sheets, both 1/2 inch thick, and that's gonna make up the main structure of the top part of the flume, including the test section. And so since acrylic is transparent, that's why we went for that as the test section material, because you want to be able to see the fish. Because Dr. Anderson actually uses this software that's able to use the silhouette that the fish creates in order to directly measure the amplitude of the tail as it flaps back and forth in the water.
Interesting. So the fish is in like a water treadmill?
Yes, it's essentially a water treadmill.
All right.
With clear sides and clear top and bottom, so that anywhere that the camera is fixed, it will have a very good view of the fish's motion and the fish's reaction to any flow rate that Dr. Anderson might want to induce.
So what is laminar flow?
Laminar flow is when any point in the flow of water has a parallel trajectory to that of any other point in the flow of the water. And so that's how we kind of define the smoothness of a flow of water. It's the opposite of turbulent flow. So turbulence is when there are a lot of vorticities and eddies in the water that are all jumbling around and making it really unpredictable where the flow is going to be. Laminar flow is all of the water within this given flow. It's all going the same direction. It's all completely parallel. And so our job is to make the flow within the flume as laminar as possible, as smooth and predictable as possible, so that the fish isn't tossed around all around this test section, because it's kind of hard to take data off of that.
She wouldn't stop shaking the bag.